Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to learn how to name alkanes with halogen substituents. So let's go ahead and start. So when you guys find that you have a halogen in your organic compound, we're going to go ahead and term that as a haloalkane. And so this word halo is coming from the word halogen. Okay? So there's a halogen in our alkane parent chain. Now, when you guys are naming haloalkanes, it's very similar to how you guys name alkanes with alkyl substituents. So like the methyl, the ethyl, the isopropyl, and all of that stuff. And so one thing that you guys have to remember is that alkyl groups and halogens, they are equal in rank. So what that means is that neither of them gets priority in terms of the numbering of the locant or the carbon on the parent chain. And so there are four halogens that we need to discuss: fluorine, bromine, iodine, and chlorine. And so if you guys are using these halogens as a substituents, or if these halogens are present as a substituent on your alkane parent chain, you guys are going to not say fluorine, bromine, chlorine, or iodine. You guys are going to say fluoro, bromo, chloro, iodo. Okay? And so the little dash that I put in here just lets you know that's attached to like something else, right? It's attached to an alkane chain. All right, so let's go ahead and take a look at our examples. We'll do 4 examples for this lecture video for this topic. So here we have this compound. We see an organic compound and they're all single bonds, so this is an alkane. So very similar to what we've talked about in the prior lecture video. The first step is to identify the longest chain, which is going to be your parent chain. So it's going to be 1, 2, 3, 4. And so here in this case, I have a branching point. I can go up, that's 5. If I go down, that's 5. So it looks like it doesn't really matter. 5 is going to be my longest carbon chain. And so since I have 5 carbons, then this is going to be pentane. Okay. So that's going to be the name of my parent chain. That means everything that I didn't highlight in pink, I'm going to highlight in now green, is going to be my substituent. And here in this case, I have this substituent. And remember, if your substituent looks like this in the skeletal structure, that's going to be representative of 1 carbon, which is a methyl group. So it looks like we have a halogen this time, and since it's bromine, we're going to say bromo. Okay. So now that we've identified our substituents, we need to determine the numbering system for this specific organic compound. And so here I'm going to go ahead and do this in 2 colors once again, blue and green. If I'm going to go from left to right, I have 1, 2, 3, 4, and 5. Okay. And so if I go from left to right, it looks like I get a substituent that's on 2, and I get a substituent that's on 4. So if I add both of those values, I'll go ahead and get 6. Now if I do this in green, I have 1, 2, 3, 4, and then 5. So I'm going in reverse. So if I'm going from right to left, let's see what my numbers are on the parent chain. So I have a substituent that's on carbon 2 in green, And then I have another substituent that's on carbon 4. And so if you add both of these up, we get 6. So the sum of these values produces the same number, and we ran across this in the previous lecture video. And so what you want to do is you want to choose the numbering system such that the first substituent based on the alphabetical order gets the lowest number. Okay. So what does that mean? Well, let's go ahead and take a look at the first letter of each substituent. I have a B in bromo, and I have an M in methyl. And so if you were thinking about how to arrange these substituents in your final answer, the B in bromo comes first before M. So we're doing this in alphabetical order. And so since B comes first before M, bromo is going to be the first substituent that we are going to write down in our final answer. And so we want to make sure that this first substituent has the least value. And so if you look at the two values, we have 2 and we have 4. That's describing that specific carbon, right? And so 2 is less than 4. So it makes sense for us to choose 2 as the number to describe the position of where that bromo is attached to on the parent chain, and not 4. Okay? And so we're going to go ahead and cross this off, and we're going to go ahead and keep the numbering system from left to right. And this time we're going to go ahead and say 2 bromo, right? So the bromine is attached to the second carbon on the parent chain according to our numbering system. And so it looks like they're on the fourth carbon of the parent chain, we have a methyl group. So we'll just say 4-methyl. Okay. And so now that we've named and identified all the substituents, and we know their numbers, their locants on the parent chain, we're going to go ahead and put them together. And so since the B in bromo is first in the alphabet, we're going to go ahead and write 2-bromo. Okay. And then we're going to now describe the second substituent, which is the methyl, which is 4-methyl. Oops. And then we're going to go ahead and describe the parent chain. In this case, it's going to be pentane. Okay. So remember, the parent always comes last. The name of the parent chain always comes last. All right, so to finalize our answer, we got to make sure that our grammar is correct, so to speak. So I'm going from a letter to a number. That means I need a dash. And then I'm going from a letter to another letter. That doesn't require anything. And the only thing we need to do is just kind of, scoot this guy over to the left, and we are done. Okay. So the name of this compound is 2-bromo-4-methyl pentane. Okay. So it's nothing new. There's nothing that we've changed in terms of like the way that we're supposed to name this specific organic compound. We're just adding in a new substituent. In this case, it's bromo. And the reason why bromo gets the lowest number is because the first letter starts with a B. All right, so let's go ahead and look at the next example. Okay. So I'm going to skip some steps here. Okay. So let's go ahead and look at this example. So here we have 1, 2, 3, 4, 5, right? And so if I go back one step, I have a branching point. So I have 1, 2, 3, 4, 5, 6. And since 6 is greater than 5, I'm going to go ahead and keep this as the longest consecutive carbon chain. So the next thing I'm going to do is number. Actually, let me determine the name of the parent chain. And so since we have 6, we know the name of the parent chain is going to be hexane. Okay, so that's in pink. All right, so we're going to go ahead and number the carbons left to right to left, see what comes up. So 1, 2, 3, 4, 5, 6. Okay. And if I go from right to left, I have 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. All right, so since I'm already on this color, I'm going to see what the sum of the values are when I go from right to left for the substituents. So let me just mark my substituents really quickly. So this is my substituent and this is my substituent. And so it looks like if I number from right to left, I have a 3. I have a substituent on the third carbon of the parent chain. And if I move on further, it looks like I have another substituent that's on the 5th carbon of the parent chain according to my preliminary numbering system. So in total, I have 8. So I'm going to go ahead and switch over to blue, and that's going to represent me going from left to right. Okay. And it looks like I have a substituent that's on carbon 2 of the parent chain, and then I have another substituent that's at carbon 4 on the parent chain. And so 2 plus 4 is 6. And so 6 is the least, so therefore the numbering of my carbons is once again from left to right. Okay. Someday green will win, but for now it looks like the numbering of left to right is predominant in these examples. No idea why. All right, so let's go ahead and now that we have the numbers on the parent chain, we figured out the numbering system on the parent chain, we're going to go ahead and describe the substituents to include at what position these substituents are attached to on the parent chain. And so we have a fluoro on the 2nd carbon, so we're going to put 2 fluoro. And I have a methyl on the 4th carbon. So this is going to be 4 methyl. All right. And now that I have my methyl and my fluoro, I'm going to go ahead and put all of these pieces together. And so once again, this is a methyl. Remember that this singular dot represents a CH3. And a CH3 is referred to as a methyl group. So whatever's not shown, we're going to assume there's hydrogens. And the number of hydrogens depends on the number of bonds that carbon already has. All right, so let's put this piece together. So we have to figure out which goes first, right? And so here in this case, we have F and we have M. And so F comes first before M, and therefore we're going to put the fluoro, the 2-fluoro, first. And then we're going to put the 4-methyl second. And now I have, since I've named all my substituents, I'm going to go ahead and add in the parent name, which in this case is going to be hexane. Okay. So just to make sure that my grammar, my organic nomenclature grammar is correct, I'm going to start combining these. So I have a letter to a number. So that represents a dash. And I have a letter to a letter. That means that there are no dashes, no commas. So I'm going to take this hexane, I'm going to move it right in there, and that is my final answer. All right. Cool. So let's go ahead and take a look at more of a complicated structure. And let's see how we can name this. So once again, first step, identify the longest carbon chain in your structure. So you have 1, 2, 3. And so this is a branch point. If I go up, that's 4. But look at all of these other carbons that's on the right. So that's probably not it. So 1, 2, 3, 4. Once I hit 4, I don't have a branch chain that there's a substituent that's on that carbon, on the 4th carbon. And so I need to go further. So 4, 5. So if I look at where I'm at right now, there's a branching. And so I can go 5, 6, 7. Okay. Or 6, 7, 8. Okay. And so since this is going to produce the longest carbon chain, this is probably going to be my parent chain. And since I have 8 pink highlights to represent the 8 carbons, I know that this is going to be octane. In terms of the name of the parent chain. And so basically everything that's not highlighted in pink, it's going to represent the substituent. Okay. And so we need to figure out how we're going to number our carbon chain, left to right or right to left. And so I'll go ahead and change my color to blue to represent the left to the right. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. And so if you look, we have a substituent on carbon 3. And we have another substituent on 4. And we have another substituent on 5. And so in total, we have 3 plus 4 is 7. 7 plus 5 is 12. Okay. All right, so let's go ahead and change our colors. And now we're going to go from right to left. So this is 1, 2, 3, 4, 5, 6, 7, and 8. And so here in this case, we have a substituent on the fourth carbon. So we're going to put 4. Then we're going to add that to, so we have a substituent on the fifth carbon. So 4 plus 5. And last but not least, here we have a substituent on the sixth carbon if we choose to number our parent chain from right to left. And so we get a total of 9 plus 6, that's 15. So once again, looks like the green lost. It produces a higher value than if we number our carbons from left to right. So I'm going to go ahead and erase all of this. Okay. Cool. So now that we've figured out the numbering system on the parent chain, let's go ahead and just name and number the substituents. And so it looks like on the third carbon, let me erase 8 and 9, or 8 and 7. On the third carbon, we have a methyl group, so this is going to be 3-methyl. And on the fourth carbon, it looks like we have an iodo. Okay, so then the last thing that we have here is on carbon 5, we have 1, 2 carbons, so that's going to be an ethyl. Okay. So now that we have all of the pieces, we need to think about how we're going to organize. I'll go ahead and circle this as well. We're going to think about how to organize our pieces so that we can name this organic compound properly. So just looking at the substituents, I'll go ahead and erase the blue for now. Just looking at the substituents, we have 3 different ones. We have iodo, methyl, and ethyl. So we need to figure out which one comes first. So here I have E, I, and M. And so since E is closest to, comes early in the alphabet, this is probably what we're going to write down first, then second, then third. And then after you guys have written all of that stuff down, then you're going to go ahead and write the parent name at the very end. All right, so let's put this together. So we have 5 ethyl. And so notice I'm going from like uppercase to lowercase, just to convey that it doesn't really matter, capitalization. All right, so we have 5 ethyl, and then we have 4 iodo. And then last but not least, we have our 3-methyl. Okay, so we're putting it in order. And then we have our octane. So before we call it a day for this specific problem, we're going to go ahead and make sure that our dashes and commas and spaces are correct. And so once again, we're going from letter to number, letter to number, letter to letter. And so if I want to do letter to number, I need to put a dash. Okay. And if I want to go from letter to number, I need to put a dash. And so since the last part is letter to letter, I'm going to go ahead and just move this over to represent that there's no space between them. Okay. And so this is going to be my final answer. 5 ethyl, 4 iodo, 3 methyl octane. All right. So this will be the last example for this section, and then we're going to go ahead and move on to naming cycloalkanes in another lecture video. So hopefully you guys are getting hang of the pattern. We're just gonna start, adding some different things to the pattern that we've kind of already established to name alkanes. All right, so first thing that I'm going to do is I am going to go from left to right, identify my carbon chain. So here, if I go up, that's 3, but there's a whole bunch of other carbons, so that's probably not the right path. So 1, 2, 3, 4. So if I go up, that's a substituent. Bromine is a substituent, so I need to keep it moving forward. 5, 6, and then 7. Okay. And so here in this case, we have 7 carbons. If you have 7 carbons, then the parent chain is heptane. So now I'm going to go ahead and identify all of my substituents in green. And now I need to figure out my numbering system. And so I'm going to go from left to right. 1, 2, 3, 4, 5, 6, and 7. Okay. So let's see what that produces. So I have a substituent on carbon 2, substituent on carbon 4, and substituent on carbon 5. So I'm going to take 2 plus 4 plus 5, and then that is going to give me, 11. All right, so let's go ahead and go from right to left. So here I have 1, 2, 3, 4, 5, and 6, and 7. And so it looks like on the third carbon, I have a substituent. On the fourth carbon, I have another substituent. And on the sixth carbon, I have another substituent. So let's add this up. So 4 plus 6 is 10. 10 plus 3 is 13. And so once again, it looks like the numbering from right to left gives us a higher value. And that is the incorrect path. So I don't want to give you guys the impression that the numbering system is always from left to right. I have no idea why it's always from left to right. I was hoping that at some point in time it would be right to left. But right to left is possible. So that's why you always want to check both numbering systems. So let's go ahead and just summarize each piece. So here I have a methyl on the second carbon. So that's going to be 2-methyl. Here I have a bromine or a bromo on the fourth carbon. So I'll put in 4-bromo. And then finally I have chloro on the fifth carbon. So to name this organic compound, all we're going to do is organize them alphabetically. And so we have C in chloro, B in bromo, and M in methyl. So which of these do you think we're going to name first? Methyl, bromo, or chloro? Okay. So if you said bromo, then you're absolutely correct. So this is the first thing that we're going to name. Then what comes second? chloro, because the C comes after the B. And then last but not least, we have methyl. And after we describe the methyl, then we're going to add the parent. So that's the fourth item that we're going to place when we're naming this compound. Okay. So here I have 5-chloro. Oops, sorry. 5-bromo. 4-bromo. So 4-bromo, 5-chloro, 2-methyl, heptane. Okay. So I've kind of skipped a couple steps there. I just went ahead and added in the dash. Hopefully by now you guys understand that when you go from letter to number, you need a dash. Or number to letter, you need a dash. So that's pretty much it. Hopefully you guys understand how to incorporate the halogens into naming your alkanes. So in the next video, we're going to take a look at cyclic alkanes and how to name them. All right, see you guys.